Hi, in this video, let's solve some problems to find the angle between the radius vector and the tangent for the polar curve. Consider the curve r power m is equal to a power m into cos m theta plus sin m theta. Sometimes they will ask us to find the angle between the radius vector and the tangent at a particular point. So in that case, finally we'll substitute that point here. Now if you see, when the power is there, whenever you take logarithm, it is easy for us to differentiate. So take log on both sides because there is a multiplication here. Okay, so log of r power m is equal to log of a power m into cos m theta plus sin m theta. We all know that two formulas we are going to use. The first one is log of m power n. Log of m power n is equal to n log m. The power will come down. And the second one is multiplication, that is log of m into n, or I can say log of a into b is equal to log a plus log b. So we are going to use these two formulas here because this multiplication will become plus and this power m will come down. So combining this on both sides, I will write m log r is equal to m log a plus, if you want you can write one more step, log a power m, and then that m will come down here, or you can write directly, and log of cos m theta plus sin m theta. So these are the formulas that we are using. Oops, and you can write using. Okay. Now it's easy for us to differentiate. So we are going to differentiate with respect to theta, because differentiate with respect to theta, because right hand side is in terms of theta. If this is in terms of t, then I will write differentiate with respect to t. That's it. So now log r differentiation is, m is just a constant, log r differentiation is 1 by r. For this I have differentiated, but I am differentiating r with respect to theta, so this is very important. So you have to write dr by d theta. For example, if I differentiate with respect to r, then I will start m into 1 by r and I will leave it. Because we are differentiating this r with respect to this theta, we get dr by d theta. So this term is very important. And on the right hand side, these are all just constant. M is a constant, log a is a constant. If you differentiate a constant, what you will get? 0. And log of something is 1 by that, right? Cos of m theta plus sin of m theta. In the numerator, we will get d by d theta of whatever extra is there in the denominator, that I will differentiate again. This is the function within a function. So for log, I have written 1 by n. So log of r, whatever it is, log of something is 1 by that something into differentiation of that something with respect to theta. So let m be as it is. What is 1 by r dr by d theta? So in the previous video we have derived that tan phi is r into d theta by dr. So this is nothing but cot phi. So just from the previous derivation, your cot phi is nothing but 1 by r dr by d theta. So we have written that as it is. And then coming to this numerator, if I differentiate cos m theta, what I will get? Minus sin m theta. This is sin m theta into m. This m is outside the theta. Okay. And then sin m theta, if you differentiate, cos m theta into m. I can take this m common and the denominator remains the same because we need to simplify further. I will write cos m theta plus sin m theta. Now in the numerator we have m common in both the terms. Okay, so I can write it as m into cot phi is equal to m if I take common, first I'll write the positive term, and which is cos m theta. I'm writing this minus sin m theta. I have written this also, divided by the denominator. If you see the denominator, it is just the positive sign that is different from the numerator. The m and m will get cancelled. Now I want cot of something on the right hand side. Okay, so if you want cot of something on the right hand side, so all we know is if I take cos m theta common, okay, so cos m theta if I take common, 1 minus sin m theta by cos m theta divided by cos m theta I'm taking common, 1 plus sin m theta by cos m theta. If I take cos common, this and this will get cancelled. Still I want cot, right, on the right hand side. So I am rewriting this as cot phi is equal to 1 minus sin by cos is nothing but tan m theta by 1 plus tan m theta. Now again on the right hand side we want cot of something, but in the derivation we look similar to it. What is that? All we know is tan a plus b is nothing but tan a plus tan b by 1 minus tan a tan b. Correct? Now if you see, the negative sign is there in the numerator. So what is 1 by tan? 1 by tan is cot. So at least you can remember this from this formula, reverse of it. So 1 by tan is cot means then the numerator will become the denominator and denominator will become the numerator. Or from this formula you can do reverse. So 1 minus tan a tan b, this is the formula for tan a plus tan b. Now what could be the value of a so that it should become 1? So we know that tan 45 that is tan pi by 4, that's equal to 1. So what I'm writing it as cot pi by 4 plus, in the place of b, what I have in the question, these are all our formula assumptions, whatever we have from here to here, or all our formula assumptions, again continuation of it. M theta we have 1 minus tan pi by 4 in the place of a, tan m theta divided by tan pi by 4 plus tan m theta, right? So this is nothing but 1 minus tan m theta by 1 plus tan m theta. What is this? Cot of pi by 4 plus m theta is this. Now I am going up and I will rewrite the term, that is cot phi is equal to 1 minus tan m theta by 1 plus tan m theta. Just now I got that value as what? That is, I got the value as cot of pi by 4 plus m theta. Just now we have got it directly. So in the place of phi, what I have? Pi by 4 plus m theta. That is why if this left hand side is cot, right hand side also I will make it cot, and I will just compare the angle. So comparing this, we get, what is phi? Pi by 4 plus m theta. So hence, thus your phi is nothing but pi by 4 plus m theta. So this is how you will find the angle between the radius vector and the tangent for the given curve. Let's see one more example. Now you see this question, find the angle between the radius vector and the tangent for r is equal to cos square theta by 2 is equal to a at theta is equal to pi by 2 pi by 3. See the solution, same as the previous problem. I have taken log on both sides. So log of r into, so it's in multiplication, and log of m into n is log m plus log n, and this is equal to the constant on the right hand side. And you can take this power from the log m power n formula. So log m power n is n log m. So 2 log cos theta by 2 is equal to log a. Now it's all set for differentiation. Now if I differentiate with respect to theta, as usual, the first term, what is that? Log r. R is not a constant. R is a function of theta. So 1 by r dr by d theta, as I mentioned, this is very, very important. And plus, now if I see here, 2 is just a constant, 1 by cos theta by 2, and this cos theta by 2 differentiation should be there in the numerator. So this is minus sin theta by 2, and theta by 2 differentiation is 1 by 2, and 1 by 2 is not the angle. So this 1 by 2 will come here. You can write it in the beginning itself. And right hand side, log a is just a constant. If you differentiate, you will get 0. And what is this 1 by r dr by d theta? This is nothing but cot phi. Okay. And this 2 and this 2 will get cancelled. You are not supposed to cancel this 2 because this is an angle. Cot phi minus, leftover I'll write again, sin theta by 2 by cos theta by 2 is 0. Now if I take this term, the second term is nothing but cot phi minus tan theta by 2 is equal to 0, which implies cot phi is nothing but tan theta by 2. Okay, cot phi is equal to tan theta by 2. Now I want cot on the other side like the previous problem. Now this is positive. Now if you see the quadrant A, here all are positive in 0 to pi by 2. And if you see this is a positive. So all are positive in this means I can write it as cot pi by 2 minus theta by 2. Why? If I write minus, then only till pi by 2 it is positive. So pi by 2 plus theta by 2 if I put, it will go to this quadrant. Here it will become sine. Only sine is positive. So in that case, I can't write pi by 2 plus theta by 2. Let me write here. So the only way is cot 90 minus theta by 2. In case if you get instead of minus, instead of plus, if you get minus, then I will write it as pi by 2 plus theta by 2 here. Okay. So cot phi is equal to cot pi by 2 minus theta by 2, which implies you can just compare the angle and directly write down the answer. Phi is nothing but pi by 2 minus theta by 2. The question is over, but still they have asked at the point, right? Just substitute at theta is equal to, they have given 2 pi by 3, which implies your phi is nothing but pi by 2 minus 2 pi by 3, which is nothing but, if you simplify this and cross multiply by taking LCM, and I must write this too, I think. Yes, because theta is 2 pi by 3 and one more by 2 will be there. This and this will get cancelled. And we have only pi by 2 minus pi by 3, which is nothing but pi by 6, which is nothing but 30 degree. In case if they ask you to find, actually our problem is over. In case if they ask you to find the slope of the tangent, it means they are asking you to find tan psi. So always in the derivation you remember psi is theta plus phi. So your 2 pi by 3 plus your phi is pi by 6. So which is nothing but 5 pi by 6. 5 pi by 6 is nothing but 150 degree. So slope is nothing but tan psi, which is tan of 150, which I can split it as tan of 90 plus 60. Okay, so tan 90 plus theta, just now I told you. Which quadrant? In this quadrant, A, S, T, C, only sign is positive. So I will get minus cot 60. So we have used both the formulas in one problem. So cot 60 value is 1 by root 3, we have minus 1 by root 3.